Today we will be learning work, energy, and power, which is chapter 8 of the CIE physics syllabus. So work is said to be done when a force is applied to an object and it moves in the same direction as the force applied. It's a scalar quantity and its formula is work is equals to force into distance covered, and its SI unit is joules, represented by capital J. So 1 joule is produced when a force of 1 Newton is applied on an object and it moves a distance of 1 meter in the direction of the force applied. So basically it's the same formula as that of work, but it's just written in terms of joules. The energy of an object is the ability of an object to do work. It's a scalar quantity as well, and the SI unit is also joules. The law of conservation of energy is that energy can neither be created nor destroyed, but it can be converted from one form to another. So the first type of energy is kinetic energy, which is the energy due to the motion of an object. Gravitational potential energy is the energy due to the change of the vertical height of an object in a gravitational field. Chemical energy is the energy obtained by a chemical reaction, for example, burning wood or coal. Elastic potential energy is the energy due to the change in the shape of an object, for example, stretching a spring or a rubber band. Internal energy is the sum of kinetic energy plus potential energy of the molecules in a substance. So as we said before, kinetic energy is the energy possessed by an object due to its motion. Its formula is half into mass into velocity square. So for example, we have a ball with the mass 500 grams and it's moving with a speed of 10 meters per second, and we have to find its kinetic energy. Firstly, we convert grams into kilograms because the SI unit of mass is kilograms. Then we input all the values in the formula, and it's half into 0.5 kilograms into 10 square, which gives us 25 joules worth of kinetic energy. Gravitational potential energy is the energy gained by an object due to the change of its position in the gravitational field. So if we move this book further upwards, the vertical distance between the book and the ground increases, so its gravitational potential energy also increases. But if we bring the book towards the ground, its vertical height is decreasing, so its gravitational potential energy is also decreasing. This shows that gravitational potential energy is directly proportional to height. Its formula is gravitational potential energy is equals to mass into gravitational field strength into height, or in short form mgh. And when mass and gravitational field strength is constant, it shows that gravitational potential energy is directly proportional to height. So next we need to understand the conversion of kinetic energy to gravitational potential energy and vice versa. So when we throw a ball vertically upwards, it has an initial value of kinetic energy, and with its increase in height, its speed decreases, so its kinetic energy also decreases. But since the height between the ball and the ground is increasing, its gravitational potential energy is also increasing. When the ball reaches its greatest height, it's at rest, so its kinetic energy is 0 and its gravitational potential energy will remain constant. But when the ball begins to fall, its speed is increasing again, so its kinetic energy is also increasing, while the distance between the ball and the ground is decreasing, so its gravitational potential energy is also decreasing. So the total energy of the ball still remains constant. Power is the work done per unit time. Its formula is work done over time taken, or energy used up during time taken. Its SI unit is watt, represented by a capital W. Efficiency is useful output power over input power into 100. So we have a question that a machine uses 100 watts of electrical power in producing 60 watts of mechanical power. What's its efficiency? So 100 watts is the input power and 60 watts is the useful output power. So we input that in the formula, 60 over 100 into 100, which gives us an efficiency of 60%. Another thing to notice is that not all the power is being used up. Instead, 40 watts is being wasted. We can tell by 100 minus 60, which gives us 40. A reason for the wastage of energy might be the friction between the moving parts in the machine, which is converting some of the input energy into wasted heat energy. There can also be other reasons. It depends on the question. So renewable sources of energy are the ones that will never run out for a long period of time. For example, wind energy and solar energy, while non-renewable resources are those that will run out eventually, for example, fossil fuels. So the first example of power generation is hydroelectric power station. So in a dam, the water is moving downwards, so it has gravitational potential energy. This gravitational potential energy is being converted into kinetic energy as it's losing its vertical height. It's moving closer to the ground, so it's turning into kinetic energy. This kinetic energy pushes the turbines. So the kinetic energy of water is being converted into the kinetic energy of the turbines. When the turbine moves, it creates electrical energy in the generator, which is then transported to wherever electricity is needed. A coal-fired power station is when coal is heated over here and it boils water. So the thermal energy of water is converted into the kinetic energy of steam, which moves the turbines. So the turbines also have kinetic energy, which is being converted into kinetic energy, which is being converted into electrical energy in the electricity generator. In the nuclear power plant, nuclear substances are in a reactor vessel. This heats up the water, which creates thermal energy. The thermal energy is converted into kinetic energy of steam, which is used to move the turbines. So the kinetic energy of the turbines is used to create electrical energy in the generator. The same is done with geothermal energy. So hot water is brought up from the ground into a chamber where steam is produced to power the turbines. When the turbines move, electrical energy is generated in the generator, which is further transported wherever electricity is needed. So the advantages and disadvantages of power generation. In hydroelectric, wind and solar, geothermal as well, no harmful gases are produced. However, in hydroelectric power specifically, the environment is at risk of floods and marine life can be harmed. In coal-fired power stations, harmful gases are produced which causes pollution, and in nuclear power plants, a large amount of energy is produced. However, its radiations are very harmful in surroundings. Next, we need to know the two nuclear processes. The first one is nuclear fission. It's when a large nucleus is split into two smaller nuclei with the release of a large amount of heat energy. So when a large nucleus of uranium is hit by one neutron, it splits into two nuclei and three neutrons with the release of a large amount of heat. This process is used in nuclear power plants and is a chain reaction, meaning that these three neutrons will collide with these two nuclei and they will further break into more parts with the release of a lot of heat. In nuclear fusion, two smaller nuclei combine to form a large nucleus with the release of a large amount of energy. This process is occurring in the sun and other stars. So these two nuclei are fusing together to form one large nucleus and a large amount of energy. Ignore the neutron. And this is the end of the chapter.